recording purposes.
All right.
All right. I do apologize.
Yeah. Thank you very much. But again, I want to acknowledge all my co-authors, David Yogi and Cenlin. They're sitting in this room. So I think all of us probably know that the latest IPCC report, provide convincing evidence that human-induced climate change accelerate climate and weather extremes. This is just a picture from this year's New York Times, so kind of trying to picture what happens. The climate tendency in the last 40 years. All this in the West, wildfire, water strikes, and relevant to us is the extreme heat tendency and the extreme rainfall, flooding in the east. So all of this obviously will affect people, and indeed, with the population increasing, all the major cities in the world, the people living in cities are suffer from various environmental risks, including thermal strikes, flooding, extreme weather, extreme climate, and the people now think about how we can maintain the water, food, energy, sustainability, and so on. But all these environmental risks in cities that ultimately connected to both the natural, physical processes and the human activities. So I think yesterday a few talks touched on this. Matt talked about it in the morning. Dave Yogi talked about the digital twin, in the afternoon. So to address all this environmental risk in cities, we need a wide range, multi-scale modeling, high-resolution models, and the data. So in this project, the overarching goal is for us to investigate the co-evolution of urban forms, land use, land cover change, and extreme temperature, precipitation, and the current and the future climate warming. And so we look at the various more urban systems that include Guangzhou, Tokyo, Singapore, Austin, Houston, and Lagos. We talk about some of these examples. So, they are ample, very rich literature, that shows the urban, indeed, cities make their own precipitation, through various physical processes, thermal, dynamic, of effect, and aerosol cloud interactions, and so on. So this is one of the early study by Shibang Miao from Beijing. He looks the extreme precipitation from a weather forecast perspective. This is probably one of the first people showing that the forecasted precipitation, very heavy precipitation event in Beijing, are very sensitive to how we treat the urban physical processes in a model. And his paper is able to show that for this specific extreme and heavy precipitation event, the Wolf urban forecasted precipitation is more sensitive to the thermal processes than the dynamic processes. And a lot of people look at in terms of climatology, case study of heavy precipitation. This is one example highlighting extreme of the extreme. A hurricane, heavy, moving over Houston, and these people by Wei Zhang and James Smith's group, what it shows is without a reasonable urban canopy model, it's not possible to capture the localized heavy precipitation downwind of the area. So again, this shows how the model precipitation sensitive to the treatment of urban processes, but to some degree also highlight the possible impact of the cities on heavy precipitation. So we did years ago a very similar results. Look at the super sandy hurricane, okay, how they were evolved, okay, in the middle of century, in the 2090, using the same five different RCP scenarios, and able to connect, okay, this high resolution of regional climate simulation results with the storm surging, okay, surge models, and to predict, okay, the flooding, okay, by the end of the century, for instance, and how that could impact the electricity grid. What's the risk, okay, exposed, okay, to that specific sector. And this is a very nice study, okay, coming from Moriarty's group. Okay. This may be the first people really look at the sub-daily precipitation extreme event. Why sub-daily? Because it only take 3 or 4 hours, very heavy precipitation, pouring on over the city and bomb, flash flood, guaranteed. Okay, so this is one of the first analyses. Look at the 40-year precipitation observations, okay, in the Pearl River Delta region in China. So this paper shows both the frequency and amount of the extreme precipitation increase, okay, much exceeds the frequency and amount increase of total precipitation. And moreover, all these precipitation extreme trends actually centered over the big cities in the Pearl River, Hong Kong and Guangzhou. This is based on observations, nothing to do with model. So the question is, and how will such precipitation extreme change in the future? So Quang-Van, a young professor at the University of Tsukuba, and he, well, asking that question, okay, use the very high resolution of urban and pseudo global warming approach to address this issue. So he looked at the two different cities, Singapore and Tokyo, which I will talk more about that in a few minutes. But the general, I mean, the novel aspect of his paper, his study, is look at is to scale the extreme precipitation increase, okay, by the Clausius Clapeyron, okay, relationship. So as we know, with 1 degree increase in temperature, there are roughly 7% increase in the atmospheric moisture content. So what he was able to show that is, is for the extreme precipitation, 99% quantile, okay, and the increase in that precipitation amount is at 3 times CC rate. Okay, that's huge, and obviously at the expense of the light and the moderate, okay, precipitation. So we are doing some coordinated research, okay, to look at the organization and precipitation of Lagos. Why Lagos? Lagos, okay, is okay to be projected as the largest city in the world with 88 million people by the end of the century. But also, they just very few studies really look at the extreme weather and climate events, okay, over this city. So again, okay, we look at the long observations, roughly 25 years, okay, which is relatively long, okay, for that part of the world. So look at how the organization, okay, impact the temperature increase, okay, in the city. So we understand there is overwhelming, okay, global warming signal happens everywhere. Okay, so this city is not, okay, exception. However, when you separate the climate change signal from local land use land cover change signal, the global warming signal only contribute 40% of the temperature tendency in the city. And the very localized urbanization, but more persistent, okay, at a local scale, contribute to 60%, okay, of the urban warming, okay, in the past two decades. So again, we look at the precipitation, change, over the Lagos, and this is again analyze roughly 30 years data site, combine different satellite image, satellite product, and in situ observations. As you can see here, if you look really hard, there's a small tendency, right, of the precipitation increase, over some part of the city, but it is not statistically significant from data. So the sky is not always blue. So we don't know why extreme precipitation increases as in some cities, why it's not. There's still a good science of the questions. So as everybody else, in this room, we publish papers, we develop models, we develop our data set. But the next step question is how this can really help people to make decisions. Doesn't matter if it's government agency or people on the street, right? So next step is really how we as community translate our scientific findings, and data into actionable science. So Dave, we talked about yesterday, the digital Earth and the WCRP lighthouse activities. So last year, about actually 2 years ago, time flies. There are 5 new lighthouse activities. One of them is they call digital Earth. On my climate risk. So I'm part of the scientific steering group try to help people to establish the regional urban hubs to address very specific urban risks. Doesn't matter air pollution, or extreme temperature, flooding, and so on. So we are working with several groups now. Try to get this regional hub, or set up. So, but anyways, this is my reflection. We are still in the early stage, really, despite all the literatures popping out in the last 5 years to understand very complex urbanization, climate change, and extreme events. A lot of science questions remain to be explored through this, and most importantly, how everything we do actually help people today or in the future in terms of the weather forecast, but consider the long-term infrastructure investment, in the future, how you cope with the future climate risk. Thank you very much for your attention.
Questions? And again, because this is recorded, use the microphone.
Thanks for the presentation. It was great. One question which reflects what I have in mind. We've been always talking about precipitation and increase for flooding. But I think that is one major factor playing in this is the changes in the chemical composition of the air and its impact on precipitation and many other factors. And until now, I haven't seen any thought of addressing the chemical composition. What's your opinion on that?
Yeah, well, I totally agree with you. I think, from beginning, there are some, probably recognition of the important interactions, right, with the aerosol, for instance, cloud interactions and atmospheric composition, impact of climate. There are two aspects of problem. One is how the climate change, right, really influence atmospheric compositions, air quality, and so on. But there's another way around. Problem is how the change in air quality, in the atmospheric composition impact global climate. Yeah, I personally attended several talks. I haven't seen much going on, but I think that's probably the next missing puzzle to understand, particularly urbanization, how urbanization impact, for instance, the ozone, and other atmospheric composition emissions and how that impact at global totally agree. I think that's why we encourage people really to tackle that scientific questions. Thank you.
Okay, that's really great. And to that particular question, chemistry is very important because it has all kinds of roles. It's nuanced, for sure, for our issues of urban, addressing urban issues. But the tools that you have are how we are going to address these issues for future climate situations. You've got to get your tools, and you need to put your quality aspect in it as well, because that's the big.
Absolutely, totally agree. I think we just need to take a more holistic and integrated approach, modeling and assessment both.
I just have another one up. Would you like the recording to be the same recording or should start a new one?
You cannot get rid of
I'm gonna end recording now.